Good morning, sir. My name is P. Charan. I am from Triple Department, Triple E section, and my roll number is 244G50201. And my topic is about current to voltage converter in op-amp amplifier applications in the subject. And we can see the brief intro about the op-amp amplifier, current to voltage converters, and operational amplifier basics, and the current to voltage conversion principle, and design a current to voltage converter, and the preference analysis of the converter, and applications of current to voltage converters, and common challenges and solutions, and conclusion for the future trends. And we can see mainly the only for we can see current to voltage converter, and its definition and the principle, and its working construction. Operation amplifier basics, the fundamental concepts of operation amplifier, op-amp amplifier configuration. Operational amplifiers can be configured in multiple ways: inverting, non-inverting type, include influencing the gain and impedance characteristics, and according to application needs. And we can see wherever we can operation amplifier and inverting and non-inverting, we can commonly use our application, and we can key key operational parameters such as input and offset voltage bandwidth, and slew rate define the performance of operational amplifier, impacting fidelity and responsiveness in the signal conversion. And this is the feedback mechanisms, and we can see the basic concepts of the operation amplifier. And first of all, current to voltage converter definition. What is this? That means a current to voltage converter using an op-amp, also known as transpedance amplifier, converts an input current to proportional output voltage using a feedback resistor. The output voltage is typically the negative product of the input current and the feedback resistance. And we can see the conception about the op-amp amplifier. This is the output of the uh, operation converts an input is the current of proportional, and output voltage is, we can see the first of all the operational amplifier inputs the current, and output we can gain the voltage by using the feedback resistor. And this is the current to voltage converter diagram, and the constructional details for the current to voltage converter. And we can see I in source positive and negative. Is positive is connected to the uh, 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 op-amp amplifier negative, and the negative uh, is connected to RF positive, and then this is the negative is connected to uh, terminal 6 V naught. And this is the uh, op-amp amplifier. This is the V1 is IB1 is equals to 0, that is the ground, and we can IB2 we can take as 0, and IB1 we can take as 0. And this is the terminal, we can say the V1 is a V1, and this is the V2, and this is the input source, and this is the output source, and we can calculate the voltage in the output source. We can see the constructional derivation for the current to voltage converter, and the derivation of the expression current to voltage converter using an operational amplifier. Let's start by considering a typical configuration known as the transference amplifier. The goal is convert in an input current IL in to a proportional output voltage V out. We can see, we can derive the last expression. We can IN is directly proportional to V naught. And since inverting input at virtual ground, V is equals to minus V is equals to 0, and we can using the for the circuit we can use the Kirchhoff law for the KCL for the circuit. And the output voltage is VA is equals to VB. This is the for virtual ground concept we can take as virtual ground concept. In is equals to, let us find the in is equals to v out minus uh, sorry, in is equals to vb minus sorry, ib1 is equals to, first of all we can take as ib1 is equals to ib2 is equals to 0, and we can take the current, all currents, we ib1 ib2 is equal to 0, and in is equals to vb minus v naught divided by rf. This is the equation number one, and we can say v, and from the circuit va is equals to vb is equals to 0, and v and vb we can also find, call v and taken as 0, and substitute vb in equation number one. In is equals to 0 minus v naught divided by rf, nothing but a field resistance, and in is equals to minus 1 by rf into v naught. This is our the final equation for the current to voltage converter, and we can take as in is equals to 1 by v naught, and we can say another equation, that is in is directly proportional to v naught in current to voltage converter, and we can finally conclude this equation, in is directly proportional to v naught, and this is the current to voltage configuration, and this is all about the its conceptual details and working principle of the current to voltage converter. Thank you, sir.